The prevailing narrative suggests discipline is a function of willpower. An examination of the biological basis of self-control, however, presents a different model. This analysis will deconstruct the neural architecture that governs behavior and assess the role of environment in systemic consistency.
A common assumption attributes failures in discipline to a deficit in personal character. This perspective frames inconsistency as a weakness of will. The data suggests this interpretation is incomplete.
The core issue is not a character flaw, but a systemic mismatch. The human brain is an evolutionary product optimized for an ancestral environment. Its core programming is often in direct conflict with the demands of modern systems that require sustained, consistent output.
This analysis will proceed in stages. First, the nature of the discipline mismatch. Second, the brain's operational efficiency. Third, the neurological bias toward immediate gratification. Fourth, the principle of least resistance. Fifth, the influence of environment over intention. And finally, a recontextualization of failure as a systems signal.
To begin, consider the brain's primary directive, energy conservation. It is not designed for consistent, high-effort repetition. Rather, its evolutionary trajectory has optimized it for metabolic efficiency. This core function is often at odds with the modern concept of discipline.
Subconsciously, the brain performs a continuous cost-benefit analysis. This can be termed the effort-reward calculus. When an action's metabolic cost is perceived as high and its reward is temporally distant, the brain's default response is to initiate resistance to conserve resources. This resistance should not be interpreted as a malfunction. It is, in fact, evidence of a system operating as designed. The brain is correctly executing its primary protocol of energy conservation. Therefore, aversion to high-effort, low-immediacy tasks is a feature of the system, not a flaw.
This leads to an examination of willpower. Willpower is commonly perceived as an abstract moral capacity. A more accurate model describes it as a finite biological resource, analogous to a depletable energy store. The act of self-control is metabolically expensive. It consumes tangible biological resources, including glucose and executive function capacity. Every instance of restraint incurs a measurable physiological cost.
Sustained mental effort results in a state known as cognitive depletion. This is the exhaustion of self-control resources. Following a period of exertion, a collapse in discipline is not an anomaly, it is a predictable, systemic outcome.
The relationship between intention and biology is asymmetrical. The metabolic cost of sustained self-control demonstrates that biological imperatives for energy conservation consistently override conscious intention. The finite resource of willpower is insufficient to overcome this deep-seated programming.
Attributing this outcome to a moral failing is inaccurate. The phenomenon is best understood as a problem of resource exhaustion. The system has simply depleted its available energy for self-regulation.
A second critical factor is the brain's inherent bias toward immediate outcomes. Neurologically, rewards that are available in the present are valued disproportionately higher than rewards available in the future. This presents a significant challenge for any system of discipline oriented toward long-term objectives.
This mechanism is called temporal discounting. As a reward becomes more distant in time, its perceived psychological value decreases exponentially. When the reward is sufficiently delayed, its value approaches zero, causing the nervous system to disengage from the associated task. Resistance becomes the automatic response. The collapse of discipline in this context is not a failure of goal clarity, it is a failure of reward visibility. From a neurological perspective, a delayed reward is intangible and provides insufficient incentive to justify immediate energy expenditure.
Having examined the internal biological processes, the analysis now shifts to external factors. The environment exerts a decisive influence on behavior. A governing principle of action is behavioral gravity. This is the tendency for behavior to follow the path of least resistance. Actions with low energetic cost are repeated, while actions with high energetic cost tend to decay over time.
This phenomenon is not an indicator of weakness, but of efficiency. By defaulting to the path of least resistance, the brain is executing its core programming for energy conservation. It is the optimal operational strategy for the system.
These principles suggest a reevaluation of the nature of discipline. The data indicates that discipline is not an internal trait to be cultivated through force of will. Instead, it emerges as a function of environmental design.
The central thesis is this: discipline is not a static personality trait. It is an environmental outcome. It is the emergent property of a system where desired actions are low cost and undesired actions are high cost. Consistent behavior, therefore, emerges under specific conditions. First, the reduction of effort required for the desired action. Second, the immediacy of the reward. And third, the strategic design of friction to discourage inconsistent actions. The objective is not to override the brain's default programming, but to align the environment with it.
This leads to the final point of analysis, the interpretation of struggle. The subjective experience of difficulty when attempting a disciplined action is not an indicator of personal failure.
Rather, this struggle should be understood as a diagnostic signal. It indicates a misalignment between a desired outcome and the existing system's design. The friction is evidence of a flawed system, not a flawed individual.
If discipline collapses when willpower is required, what does that suggest about how discipline actually works?